Hi. So we are in the process of creating our new generative art system called Ashtree that generates pretty pictures like these ones. And in the process, we're learning something about how functions work in R. So where we left things at last time was we had just finished writing this little function in R called radians that converts degrees that can go from 0 to 360 to radians, which go from 0 to 2 pi. The reason we have this function is that human users tend to think about angles in degrees, and machines tend to think about them in radians. Makes it more convenient for trigonometry stuff, which we're going to need, unfortunately. So we are. So this is where we're up to. We just coded this function. What we want to do now is have a moment just to be clear or recap a little bit about what the structure of this function is. So our next thing is, what are the different parts of a function? The function we just created has this kind of a structure. It's got a name, radians, and that's the thing when that is on the left-hand side of the assignment operator. They have arguments that they take, and those are specified inside the function, inside the round brackets. And then they have, at the bottom here, we've got some value that gets returned to the user. And you can see in these slides, I've used the expanded version that had the internal variables that I showed you in the last video. So it's got an explicit statement of what the return value is. So this is really just a restatement of that. Functions are regular R objects. They can be treated, they can be worked with in very much the same way as any other object in R, any other variable. The last thing I want to point out about them is that all this stuff on the inside the function body, takes place in its own environment, as I mentioned before, and these internal variables, if you create them, prop and rads, are not visible from the workspace. The only thing that the user sees at the end is what the return value that pops out at the end, the rads thing. Okay, so that's about where we're up to. We should now, I think, have a go at creating something. Like actually draw something. Create a thing and then draw it. That's going to be our goal. Okay, so to do this, we're going to work within tidyverse. So I will, as usual, have a thing up the top that says library tidyverse. And because we're doing generative art that uses random numbers or pseudo-random numbers, I'm going to have a line in here that controls the seed to the random number generator. And for now, we're just going to say seed equals 1, right? So that's the seed. And in order to keep our code nice and clean and usable, I'm going to insert some sections just so that we know what's going on. So I've got here, the first one, Control-Shift-R brings this up, and we'll just call this setup. And then the second section we've got here, this is not like, this function here doesn't do anything artistic or interesting. It's really just there to help us out. So I'm going to call that a helper function, and I will call this section helpers or helper functions. Okay, so we've got that. Now we're going to start with a new section called tree, I guess. I don't know. Control-Shift-R, grow tree. That'll do. Okay, so what I want to do is have a data structure that describes the smallest possible tree, one that has just one segment that grows from the ground at the bottom and goes up. So we'll call that thing a sapling. And the data structure we'll say it's going to be a tibble. So we'll go tibble, and that's part of tidyverse, so that's cool. We don't need to load any other packages. And we're going to define our sapling in terms of 6 columns. So the columns that we need are going to correspond to the all of the pieces of information about a sapling. So we need to have the point at the bottom, its x and y coordinates, the point at the top, x and y coordinates. So we'll call the ones at the bottom the old coordinates, the ones at the top are the new coordinates. And for the sake of my sanity as a programmer, I'm also going to explicitly record what is its orientation, what's its angle, and I'm going to also record how long it is, so what's its scale or length. So those are our 6 variables. So let's just let's just specify them. So old x, so we're going to start at the origin. So the initial x coordinate is 0, the initial y coordinate is 0, the initial x coordinate, so the end x coordinate is still 0, it's going vertically, so the x coordinate doesn't change. And it's going to go up, and we'll say it'll go up a distance of 1. So that's new y equals 1. Okay, so we've got a line that goes like that. Its length is 1, so we can immediately say scale equals 1. And its angle from the ground is 90 degrees, so we can go angle equals 90. Okay, so let's just save that again, and now Control-Shift-S source it, and we're running it. We can see that we have, so over here, you've got all the stuff that tells us, yep, we've just loaded tidyverse. We have created our radians function. Haven't actually used it for anything, but we've created it. And we've created this new sapling object. And you can see what its values look like there. So it's a tibble one with 1 row. If I just click on that, there you go. There's the sapling. It's got 1 row and 6 columns. Okay, so this is the smallest possible tree that we could have. In order to not be bored to tears by our code, let's set it up so that every time we run our script, it actually just draws the tree for us. So at the moment, our tree is just called sapling, but later on as we grow it, it's going to have its own name, right? So I'm going to call that, I'm going to say tree equals sapling. This is kind of just at the moment, this is boring. This is just saying the tree is the same as the sapling. Later on, the tree could be quite different. So we've got that line. The next thing I want to do is I'll create a ggplot object. So I'll just say pick get ggplot of the tree, and I'll name my arguments. I try to be good like that. Data equals tree, and the mapping, we really just want to draw a segment that goes from the old x values up to the new x values. So the mapping we need is going to look like this. And that's where we start specifying our aesthetics. So if we just remember for a second what our variables and our data frame look like. I don't know why my computer decided to freeze there. Okay, so the x and y values are going to start here and they're going to end there. So that would mean that our aesthetics are going to be x equals old x, y equals old y, and then we have x end, so that's just the end of the segment, the x coordinate of it is going to be new x, and then y end is new y. Okay, that's our mapping. We've specified the plot, and now we'll just add the geom. The geom segment understands all of those aesthetics, so we can just do that, and that's how that will create our plot. Assign it to this variable pick, and then we'll just go plot pick at the end, so that at the very end of our code, it's going to draw the picture for us. That looks good. let's have a go. Let's save that. Let's source it. Let's hope I haven't made any errors. And hey, it's drawn us a picture. Cool. All right. That is a good sign. We can tidy up that plot if we want a little bit by saying, well, let's not have all of this stuff, the thematic parts of the plot that are useful if this was, an actual line graph of some kind. But this is art and I don't want ggplot backgrounds there. So we'll just go theme void, which will strip out all of the paneling and legends, axes, thingies. And I will also do coord equal to make sure that the x-axis scale and the y-axis scale are the same. Okay, save that, source that, and we have something that looks like it draws us a line. Okay, cool. We are making progress. This seems like a natural spot to end this one. What we want to do next after this point is going to be, well, how do we grow the tree from there? Like, we've got one little sapling, but what we're going to need to do is a bunch of operations on that sapling and add the branches as we go to start drawing some pictures. And that will be the topic of the next one. All right, I'll stop that one there.